Every developer chasing AI right now is obsessed with the same question. Which model is smartest? GPT, Claude, Gemini? Which one writes the best code? Wrong question. The engineers actually shipping production systems with AI in 2026 stopped asking that months ago. They figured out something the rest of the industry is still catching up to. The model was never the bottleneck. The memory was. Today I'm going to show you why vibe coding quietly breaks the moment your codebase gets real, what actually replaces it, and why even that replacement, context engineering, is already being outgrown by something bigger. By the end of this video, you'll understand the exact architecture serious AI engineering teams are running in 2026, and why the next skill to master isn't prompting, it's intent. Let's get into it.
Let's talk about vibe coding because it's genuinely incredible for what it is and genuinely dangerous for what people are using it for. The dopamine hit of watching an AI spit out working code in seconds is real. It's addictive, and it works beautifully for weekend hacks, prototypes, one-off scripts. But vibe coding runs on raw intuition. You shout a prompt, you eyeball the output, you shout again if it looks wrong. That loop works when the stakes are low. It collapses the moment you're working inside a large, messy, brownfield codebase with years of history and edge cases. Here's the diagnostic. In a recent State of AI survey, 76.4% of developers said they have low confidence shipping AI-generated code without rigorous human review. Let that sink in. 3 out of 4 developers don't trust the output enough to ship it blind. And it gets worse. Stanford researchers studied 100,000 developers and found that unstructured AI engineering causes massive spikes in code rework, actually slowing engineers down on complex tasks, not speeding them up. Here's the line that sums it up. A bad prompt is a bad line of code. A bad contextual plan is thousands of bad lines of code. That's the trap. Vibe coding doesn't just fail, it fails at scale.
So what's the actual difference between vibe coding and the discipline that's replacing it, agentic or context engineering? It comes down to methodology. Vibe coding is intuition-based, shout and pray loops. Agentic engineering is structured, state-based, and deterministic. One is vibes, the other is process. The primary mechanism shifts too. Vibe coding is all about prompting the model, finding the magic words. Agentic engineering is about managing the context, controlling exactly what information the model sees and when. And the impact is almost philosophically different. Vibe coding raises the floor. Suddenly anyone can code, regardless of experience. That's genuinely powerful for accessibility. But agentic engineering preserves the bar. It's the discipline that keeps you from introducing vulnerabilities and regressions into professional software. The code interaction says it all. Vibe coding blindly commits whatever jars and assets get generated. Agentic engineering is spec-first. You write the rigorous specification, then you throw away the scratch prompts and commit only the disciplined result. As Andre Karpathy put it, agentic engineering is about preserving the quality bar of what existed before in professional software. You are not allowed to introduce vulnerabilities due to vibe coding. That's the line every serious AI engineering team draws today.
To understand why context is the real battleground, you need a mental model. Think of the AI system as a computer. The CPU is the LLM. It's a pure function, stateless and brutally simple in concept. It just processes whatever input it's given. It doesn't remember anything on its own. It's a highly capable interpreter operating purely in the digital information space. The data bus is your prompt and your tools, the pipes physically feeding information into that CPU. And then there's the RAM, the context window. This is the volatile, highly restricted working memory of the entire system. And right now, it's capped around 170,000 tokens. Here's the core concept that changes everything. The model is not a chatbot. It's a processor. And if the only thing that changes the quality of a pure function's output is its input, then optimizing the RAM, the context, is the single most critical task in AI development. Prompt engineering is merely writing CPU instructions. Context engineering is managing the entire operating system. That reframe is everything. Stop thinking about clever prompts. Start thinking about memory management.
So what happens when you get memory management wrong? The neural computer crashes, and it crashes in four very specific, very predictable ways. First, context poisoning. A hallucinated fact or a bad tool response enters the context, and because models trust their own history, it gets recursively referenced, corrupting every output that follows. Second, distraction. The model fixates on a massive, irrelevant history log instead of generating a fresh, accurate plan. It's drowning in its own past instead of focusing on the task in front of it. Third, confusion. Extraneous, unrelated details, often introduced by poorly filtered retrieval, nudge the model toward completely incorrect logic paths. And fourth, clash. Two injected sources quietly contradict each other. The model has no explicit instruction on how to resolve the conflict, and it just guesses. This is what happens when the context window gets treated as a dumping ground for conversational history and massive JSON blobs instead of a carefully curated workspace. And once you see these four failure modes, you start noticing them in almost every broken AI agent you've ever used. So how do you actually fix this? You stop padding prompts and you start curating tokens. This is the WSCI framework. Write, select, compress, isolate. And it's a ruthless, programmatic approach to information architecture. Stage one is write, saving state outside the volatile window so the agent isn't relying on cramming everything into active memory. Stage two is select, pulling only the exact required signals out of everything available. Not the whole haystack, just the needle. Stage three is compress, condensing histories to preserve space so old information doesn't crowd out what actually matters right now. And stage four is isolate, sandboxing execution to prevent crosstalk between tasks that have no business interacting. Raw data goes in one end, messy, chaotic, unstructured. Curated context comes out the other end, clean, minimal, and exactly what the model needs to do its job well. This pipeline is the difference between an agent that degrades over a long session and one that stays sharp from token 1 to token 100,000. Let's break down each stage in more detail. Starting with write, persisting state. The mechanism here, agents need external scratch pads and long-term memory, usually vector databases, to record intermediate plans, open questions, and completed steps. The outcome is huge. It prevents the context window from being flooded with the agent's own internal monologue across a long-running session. Without this, an agent thinking out loud for an hour will drown itself in its own notes. Now, select, curating signal. The mechanism is hybrid retrieval, combining semantic and keyword search. And the golden rule here, do not dump full documentation into the context. Instead, extract only the specific log slice, the specific policy line, or the top handful of facts required for the exact current turn. The outcome is that this eradicates context confusion and limits token expenditure, ensuring the CPU, the model, only ever processes high signal data. This is where most amateur AI workflows fail. They retrieve everything just in case. Disciplined engineers retrieve exactly what's needed and nothing more. Now compress, intentional compaction. There's a hard rule here that surprises most people. Never exceed 40% context utilization. Not 80, not 90, 40%. The mechanism. When approaching that threshold, you programmatically summarize long histories into loss-aware 3-line recaps. You drop stale tool outputs and keep only the last 5 raw steps for safety. That 40% number matters because it leaves headroom. A context window that's constantly near capacity is a context window one bad turn away from collapse. Then, isolate, sandboxing subagents. The mechanism. Route heavy tasks, like reading 100 files to find one authentication endpoint, to parallel subagents each with their own distinct context window. The outcome: the subagent returns only a specific file name and line number to the parent agent. This prevents context poisoning and isolates all that noisy tool calling from the main thread. Together, write, select, compress, and isolate turn a fragile dumping ground context window into a disciplined, engineered system. Here's what this looks like when you actually put it into practice. The before picture is what most people are still doing. Shout and pray. Round and round in an unstructured loop, hoping the model eventually lands on the right answer, until it hits a wall and just fails outright. The after picture replaces that chaos with a deterministic, phased pipeline. Phase 1, research. The agent maps the relevant files and lines. Then there's a human checkpoint to verify the agent actually understood the problem correctly. Phase 2, plan. The agent writes an exact markdown spec and the context gets cleared. Another human checkpoint, a spec review. Then phase 3, implement. The agent executes on a completely fresh context window. This isn't theoretical. This exact framework successfully one-shot a fix into a 300,000-line Rust codebase, the BAML project, and generated 35,000 lines of complex systems code in Go in a single day. That's the payoff of disciplined context engineering. But there's a twist coming, because context alone, it turns out, still isn't enough. Let me show you why. This is the Klarna paradox, and it's the case study that changes the whole conversation. Klarna deployed an AI agent to handle 2.3 million customer conversations. Resolution times dropped from 11 minutes down to 2. The company saved $60 million. On paper, an unqualified success. Then came the failure. The AI was technically brilliant, but optimized for exactly the wrong objective. It was robotic, generic, and it damaged customer relationships badly enough that Klarna had to rehire human agents to undo the harm. Here's the diagnosis, and it's the most important idea in this entire video. The agent had perfect context. It knew every policy inside and out, but it had zero intent. It didn't understand that the real goal was customer retention, not blind efficiency. It could not weigh the trade-off between speed and generosity because nobody ever told it that trade-off existed. Context tells an AI what it needs to know. Intent tells it what it ought to want. Klarna nailed the first one and completely skipped the second, and that gap cost them trust that $60 million in savings couldn't buy back. This is why enterprise AI is maturing through 3 distinct stages. Stage 1, back in 2023, prompt engineering. The focus was simply how to talk to the AI. The scope was individual, synchronous, session-bound. The output was text generation and isolated code blocks. Stage 2, roughly 2024 through 2025, where most serious teams are today, context engineering. The focus shifts to what the AI needs to know. The scope becomes systemic, RAG pipelines, MCP servers, shadow agents running in the background. The output is complex task execution and autonomous research. But now we're entering stage 3, starting in 2026, intent engineering. The focus is what the AI ought to want. The scope is organizational goals, value hierarchies, trade-off boundaries. The output is autonomous decision-making that's actually aligned with corporate strategy. Not just technically correct, but organizationally correct. Klarna's agent was a stage 2 system dropped into a stage 3 problem. That mismatch is exactly what broke it. So how do you actually build intent into a system? Agents do not absorb company culture through osmosis. They need a cascade of specificity that encodes human judgment into machine actionable boundaries. It starts with a human aspiration, something as simple as increase customer satisfaction. That gets fed through goal translation infrastructure and broken into 4 concrete outputs. Actionable objectives, what signals actually indicate satisfaction, and what data sources hold them. Decision boundaries, when request A conflicts with policy B, what's the resolution hierarchy? Value trade-offs, explicitly defining the weight of cost versus quality or speed versus thoroughness. And feedback loops, mechanisms to measure and correct alignment drift over multi-week deployments, because intent that's correct on day 1 can quietly drift off course by week 6. This is the machinery Klarna was missing. A vague OKR, like increase customer satisfaction, means nothing to an agent unless it's translated into these 4 concrete machine-readable layers. Let's put the whole picture together. The complete neural computer stack, top to bottom. The base layer is the compute engine, the frontier models themselves, GPT, Claude, Gemini. Commoditized intelligence. This is the stateless CPU operating purely on whatever the layers above it feed it. It powers the system, but on its own, it has no direction. The middle layer is context infrastructure, the WSCI framework we walked through. Write, select, compress, isolate. This includes the model context protocol, sandboxes, and state management. It feeds the system with clean, curated information. And the top layer, the newest and the one most teams haven't built yet, is the intent framework. Organizational alignment, machine-readable goals, decision boundaries, escalation hierarchies, capability mapping. This is what directs the system. And here's the core insight of this entire video. The race is no longer about who has the smartest model. Every serious lab is converging on roughly the same frontier capability. The race is about who builds the most robust context and intent infrastructure to aim that model. The model is the engine. Context and intent are the steering wheel and the map. An engine without a map just goes fast in the wrong direction. This stack doesn't just change how AI behaves, it changes what a developer actually does all day. Here's the from. Developers reading and debugging 20,000 lines of AI-generated code, hunting through walls of text for hidden race conditions. Exhausting, error-prone, and honestly, not a great use of a skilled engineer's time. Here's the to. Rigorously reviewing 200 lines, the implementation plan, the context boundaries, the intent specifications, reviewing the blueprint instead of auditing every brick. One developer living this shift put it perfectly. I haven't opened a non-markdown file in an editor in almost 2 months. I no longer read every line of code because I read the specs and I know they're right. That's not a smaller job, it's a different one. Further up the stack, closer to judgment and intent, further from syntax. So where does this leave us? The age of humans just know is ending. The arrival of long-running autonomous agents demands that we make the tacit explicit. Every assumption, every trade-off, every boundary that used to live quietly in a senior engineer's head now has to be written down in a language a machine can act on. And here's the line to leave you with. Context without intent is like a loaded weapon with no target. All the capability in the world aimed at nothing, or worse, aimed at the wrong thing, the way Klarna's agent was. We've spent years building AI systems. The next decade belongs to the engineers who learn how to aim them. If this breakdown of vibe coding, context engineering, and intent engineering helped clarify where AI development is actually heading, subscribe for more deep dives into GeoAI and the systems shaping how we build with AI. And drop a comment with which stage your team is actually operating in right now. Stage 1, Stage 2, or are you already building for Stage 3? Thanks for watching.